Welcome to this video. This is lecture number 58. Already 57 lecture covered the solution of the supplementary problem of the book Vector Analysis by M.R.Spiegel. You know this book is very important for physics as well as for mathematics and also important for IIT JAM examination. That's why we decide to solve the supplementary problem of this book. In this video, we want to solve the supplementary problem 6.51 to 6.52 of chapter 6, which consists divergence Stokes related integral theorem, mainly Green's theorem. If you want to see the previous lecture, you get the link in the description box. You can go through this description box. Okay, so let's start with problem number 6.51, which says that by changing the variable ux, changing xy to uv. According to the transformation, x is a function of uv and y is a function of uv, so that the area A of a region bounded by a simply curve C, for any curve, this is a curve and this region is R, this curve is C. This bounded area will be given by this, where J is the Jacobian and where is the restriction Euclid. You know from the previous lecture, if you don't know, go through the previous video. You can award that the area of any closed curve can be written as half integration x dx minus y dy. This is the integration of any closed curve. Okay, so we want to transform the xy to uv. Xy transform into the uv. If I want to transform the xy into to uv, though what will be the happen? X is nothing but x is a function of uv, and what will be the dx? Since x is nothing but x function of uv, so you can say dx is nothing but del u del x that into dx plus del u del x del u that into du and del x del v that into dv. Similarly, y is function of uv, so you can say dy is nothing but del u del u del y by del u that into du plus del y by del v that into dv. Just replace here dx. What is the value of dx? Dx is nothing but del x del u that into du plus del x del v that into del dv. This is dx minus y, which is also function of uv, this is v, into dx. This is not this is dy and this is dx. Dy means this is y and this is y, and dx means del x del u into du plus del x del v into dv. Clear? Just push this value, and you can write with respect to u and v. So x del y del u, I write this only x function of uv. You know this function of uv, and del u here minus y del x del u that into du, right? And plus x del y del v plus minus y del x del v that into dv. Okay, so by Green's theorem, by Green's theorem, you can say that integration m dx plus n dy can be written as surface integral of del n del x minus del m del y that into dx dy. Here this is a function of uv, so this is written as m and this is written as n. So m is written as the x del y del u, x del y del u minus y del x del u, right? Del x del u, del x del u. Clear? So if we want to change into, since this is a function of uv, so you need to derivative m with respect to v and partial derivative n with respect to u. So del u del v del m del v will be del x del v, that into del y del u plus x del 2y del u del v minus del y del v, that into del x del u minus y del 2x del u del v. Clear? Similarly, n is nothing but this is the n, which is x del y del v, x del y del v minus y del x del v. So del n del u, so this is del x del u into del y del v plus x del 2y del u del x del u del u del v minus del y del u, that to del x del v minus y into del 2 x del u del v, right? So from Green's theorem, you know, we need to find the del, we need to find the del n del u minus del m del v. If you subtract this to that, you can see these are cancel out, these two are cancel out, and this is becomes minus, this is plus, this is nothing but the same. So you can see this is 2 del x del v del y del u minus del x del u del y del v. Just check, this will be the value of this. And from Green's theorem, you know, there is a half, so the area will be, area can be written as half, and this gives you this. So these two will be cancel out, these two will be cancel out to integration this term. This is del x del v del x del v del y del u minus del x del u minus del y del v into du dv, since we already changed the, okay. So this is uv, so this becomes del u del v. Clear? And this can be written as determinant of xy Jacobian xy uv. you know you know Jacobian xy uv is nothing but del x del u del x del u del y del u del x del v del y del v. So need to multiply these two, that is del u, del x del u into del y del v. You will be get this expression, okay. And you need to minus that from that, so there is a minus, I mistake this, just correction, there is a minus, so there is a minus, okay. This term is minus, this term is plus, so this will give you the Jacobian. This is proved in the first part, which already described. What restriction should you make? Here the restriction will be, you must, this will be the function will be continuous variable, This will be given in the previous lecture. You can see the continuous variable. For that you must can be written as that. Okay. And next one is the illustrate the result where uv is the polar coordinate. If uv are the polar coordinate, now if uv are polar coordinate means u is r and v is theta. You know the polar coordinate is any point can be written at xy. Change this is r and this angle is theta. You know this very well. So if we change this, we need to find out the Jacobian. So for that you need to find out the x, you know, r cos theta, y is r sin theta, u is r and v is theta. So del x del u is nothing but del x del r. If you partial derivative with respect to r, this gives you cos theta. And what is the value of del x del v? That is del x del theta. If you derivative with respect to theta, this will minus r sin theta. And del y del u will give del y del r. This is sin theta. And del y del v, that is the del y del theta. Del y del theta. What is the value of del y del theta? That is the r cos theta. Put here. We need to find out the Jacobian. So Jacobian x y and uv is the r theta. So this is nothing but that into that into that into that. Del u del x del x del u, which is cos theta, into del y del v means del y del v is the r cos theta minus minus del x del v, that is minus r sin theta, that into del y del u, that is sin theta. So if you multiply and take r is a common, you will be get cos square theta plus sin square theta, which is 1. So this will be becomes r. So here the will be r. So area will be Jacobian is the r, and du is the du will be dr, du will be dr, and dv will be d theta. So this is dr d theta. This is the small area in the polar coordinate system. Clear? And this formula is used in the previous section. I already discussed in the previous section when I say that will be put in the forward video, and this is the proof that in a polar coordinate system small area will be the r dr d theta, and this will be the standard formula, that is the area of any coordinate system. This will be the using by this formula. Clear? This is a very important question. Go to the next one. I think this question is clear. Huh? Next question, where we need to find out the evaluate this integral. This is the surface integral. We need to find out this surface integral. We need to find out this surface integral where f is the given here, the force is given here, the surface of the parallelepiped bounded by this. Okay. So here we introduce the Gauss theorem, Gauss divergence theorem. Gauss divergence theorem says Gauss divergence theorem. Gauss divergence theorem says any closed surface integral f dot ds is the volume integration divergence of f dv. This is the volume integral. Okay. So this is the Gauss divergence theorem. For that you need to a closed surface. Here the surface of parallelepiped also closed. That's why we can use the Gauss theorem. There is no problem. And there, if there is a discontinuity, then we cannot apply. But there is no discontinuity, so we can apply this Gauss theorem. There is no problem. I want to draw this parallelepiped. You can see there is a x-axis, y-axis, z-axis. X is 0, you know this plane is x is 0. y is 0, y is 0 is this plane is y is 0, and z is 0, that is the z plane is 0, and x is 2, that maximum x value is 2, like here this is the x is 2, this is x is 2, y is 1, so you must draw this y is 1, so this is here, and z is 3, so this become larger. So actual if you want to draw like that, z is 3, uh, x is 2 and 1, so this is like that. Clear? Like that, this is a closed volume. Okay, so for closed volume we need to find out the divergence of A. What is the value of divergence of A? So this is, you know, del x del f del x plus del f del y plus del f del z, x y z. So the component of x is 2xy, so this is del x of 2xy, and del y of, you know the divergence very well, and if you don't know, go through the previous lecture, you can see this here. And this is the del z of fz, fz is xz, right? So this is will be 2y, and this gives you z square, and this gives you x. This is the value x plus 2y plus z square. This is the value of this divergence of A. Now you need to find out the integral, that is the volume integral x plus 2y plus z square dx dy dz. Here at first I want to integrate with respect to x. X is changed from 0 to 2, so if you integrate with respect to x, this become x square by 2, this is 2y plus z square, that into x into dy dz, and x is here 0 to 2. Put x is 0, this is 0. If you put x is 2, this become 2 square is 4, 4 by 2 is 2, and this is 2, so this is 2, 2y plus z square into dy dz. So this is 2 plus 4y plus 2 z square, 4y plus 2 z square dy dz. The value of y is changed from 0 to 1, so value of y is changed from 0 to 1, y is changed from 0 to 1. Put the value of y, so this is 2y, and this 2y square, this is 2z square into y, and y is 0 to 1 digit. So put the value y 1, so this is 2, this is 2, and this is 2 z square dz. Integration already done, so there is one integration, and z is 0 to 3, z is 0 to 3, put z is 0 to 3, so this become 4z plus 2 by 3 z cube 0 to 3, so this is 12, and 3 cube also 3 square 9 to 18, that gives you 30. This is the answer of this question. Using Gauss theorem, we can find out the, you can also find it directly, but this method will give you consume the time, because there is no mention to use indirectly or Gauss theorem, so we can use any method. In the forward question we will see that there will be mentioned is directly process or in the Gauss theorems, then we need to strictly follow this method, but here there is no mention of the Gauss theorem or the directly, so we can use any of this method. Gauss theorem is very easy, that's why we use this method. Clear? Next question says the surface of the region bounded by this. Here also it is closed bounded, so we can also use Gauss theorem. For Gauss theorem, you need to find out that divergence phi. Divergence phi already calculated, x plus 2y plus z square, x plus 2y plus z square, x plus 2y plus z square. Here this y is changed from 0 to 3 and x z related to that. So x can be written as 6 minus 2z. So x is changes from 0 to 6 minus 2z, and z will be changed. If we put x equal to 0, z will be 3. So z will be changed 0 to 3. So you need to integrate with respect to x first, then z. At first we need to integrate with respect to y because this is independent on xy. So the volume integral xy here. Okay, at first we need to write this one, x plus 2y plus z square, that into dx dy dz, right? So at first we want to find out integration with respect to y. So this is with respect to y, this is xy, this is y square by 2, that is y square, that is z square y, and the y is 0 to 3 and dx dz. So put y equals to 3, this is 3x, this is y square is 9, this is 3 z square dx dz. So at first you need to integrate with respect to x. So this is 3 by 2 x square, this is 9x, this is 3 z square into x, and the x is changed from 0 to 6 minus 2z dz, right? So put the value of x is 0 is 0. If we put here, this is the 3 by 2 x square, that means 6 minus 2z whole square plus 9 plus 3z square x is nothing but 6 minus 2z, that into dz, and the z will become 0 to 3. So we need to integrate of this integration, try to this solve. uh, there is a mistake. So this become 0 to 3, this is 3 by 2, and this becomes 36. Now you can to take as a common, you will get 4 here, right? So 4, so this is will become 6, and 3 as a common, so this will be 9. 9 into 3 into 2, that is 6z plus z square, and this is 54, this is 18z, this is 18z square minus 6z cube whole into dz. Clear? So this is 0 to 3. So we want to rearrange this, 54 minus 36z plus 6z square plus 54 minus 18z plus 18z square minus 6z cube, that into dz. Z equals to 0 to 3. So there is 6z cube, so right here minus 6z cube, z cube square 18 z square and 6, that is the 24 z square. And what is the z? Z is 18 z 36 54 54 no minus, this will be the minus 54 z 54z, and this is the 54 54, this is the 108, this is the 100 and 108 108. Is this clear? 108, is it clear? That is z, and z will becomes 0 to 3, z to the 4 by 4. So this is 3 by 2 z to the power 4 plus 8 z cube, and minus this will be written 2, and this is the 4 27 z square, and this will be 108 z. Okay, just put the limit 0 to 3. So this become minus 3 by 2, 3 to the power 4 minus 8, so plus 3 3 cube minus 27 3 square plus 108 into 3. Just calculate this, you must be get 1 351 by 2. So this is becomes 3 to the power 5. 3 to the power 5 means 3 to the power 5 means 243 by 2 plus 3 cube. 3 cube means 27 into 8. This is 216 minus 27 into 3 square 9. That's equal to 243 plus 108 into 3, that is 324. So if you calculate this 324 minus 243 plus 216, that is give you 297. So minus 243 by 2 plus 297. 297 minus 243 by 2, that gives you 351 by 2. This gives you 351 by 2. This is the answer of this question. If there is any query, you must comment in the comment box. This is all about me. This is my contact. You can contact with this my WhatsApp or the Telegram channel regarding physics related question. And this is my YouTube channel. Go to this channel. You get the all videos which already uploaded, and share this video to your friends so that she or you will get benefit from this video. Subscribe this channel if you new in this channel, and press the bell icon to get the notification of upcoming video. Take care. We'll meet in the next video as soon as possible. Thank you.